when n number of particles of masses m, 2m, 3m, and so on nm are at distances of x1 equal to 1 meter, x2 equal to 2 meter, and xn is equal to n meters respectively, then find the distance of the center of mass of the system from the origin. So if you observe here, all particles are on the x-axis only. So x1, x2, and so on xn. This is the origin. Along the origin, with respect to the origin, I considered one x-axis. On the x-axis, 1 meter distance, small m mass is present. At 2 meter distance, 2m mass is present. At 3 meter distance, 3m mass is present. At n meter distance, nm mass is present. Now, as you know that the position of center of mass with respect to x-axis, formula is xcm is equal to, what is the formula? m1 x1 plus m2 x2 plus and so on plus mn xn by total mass, m1 plus m2 plus and so on, like that, mn particles. Now, mass of the first particle m, distance of the first particle from the origin, what is that? 1 meter. m2, what is the mass of the second particle? 2m. What is the distance of the second particle from the origin? 2m, nothing but 2 meters, plus and so on. What is the mass of the nth particle? nm. What is the distance of the nth particle from the origin? What is the distance from the origin? n. So I consider n by total mass m plus 2m plus and so on plus nm. Like that, if you consider 1, I wrote here 1 square. In each and every one m is present. Take out the m as common. 1 square. 1 square means 1 only. 2 into 2, 2 square. 3 into 3, 3 square. N into n, n square, like that. So we are taking the sum of all these things. Next, take the m as common. M as common here. 1 plus 2 plus 3 plus and so on plus n. So here you need to learn these two formulae. The first one is nothing but the sum of integers 1 plus 2 plus 3 plus and so on plus n is equal to, what is the formula? N into n plus 1 by 2. The sum of the square of the integers 1 square plus 2 square plus 3 square plus and so on plus n square is equal to, what is the formula? N into n plus 1 into 2n plus 1 by 6. Okay, so now substitute this formula and this formula in this equation. 1 square plus 2 square plus 3 square plus and so on plus n square is equal to, what is the formula? N into n plus 1 into 2n plus 1 by 6. And then 1 plus 2 plus and so on plus n. What is the formula? N into n plus 1 by 2. If you substitute this formula and this formula in this equation, then you will get this one. You will get this one. N into, this is sum of square of the integers, and this is the sum of the integers. So then n into n get cancelled, n plus 1 get cancelled, 2 1s are 2 3s are 2n plus 1 by 3. This is the position of center of mass with respect to x-axis. Okay, just take a look on this. Fine. Now, so I'm taking another problem. So I'm taking another problem, and this is the another one. Just take a look on this problem. So everyone is one different model. If you know all these models, then it is very easy to do the numericals, and it is very easy to understand the center of mass topic. Listen, the position vector of 3 particles of masses. So here in this problem, 3 particles are given. One mass is 1 kg, second mass is 2 kg, and third mass is 3 kg. And these 3 masses are at 2 different positions. Nothing but R1 bar, given that I cap plus 4j cap plus k cap, and then next position vector R2 bar I cap plus j cap and plus k cap, and then R3 bar is equal to 2i cap minus j cap and minus 2k cap meters. So 3 masses are given, and these 3 masses are at 3 different distances. First one is nothing but I cap plus 4j cap plus k cap. second particle is at a distance of I cap plus j cap plus k cap, and the third particle is at a distance of 2I cap minus j cap minus 2k cap meters respectively. Find the position vector of their center of mass. Their center of mass. It means here we need to calculate the RCM. Which one? Position vector of their center of mass. Nothing but we need to calculate the RCM. RCM is equal to how come we consider that? Listen carefully. RCM is equal to M1 R1 bar. Nothing but if you consider the bar like this, M2 R2 bar plus M3 R3 bar. Three particles are there, so three terms. M1 R1 bar, M2 R2 bar, M3 R3 bar. Take the sum. And then again, total mass M1 plus M2 plus M3. Now, here, why? Because R1 bar, R2 bar, and R3 bar, these are the vector representations. Why I consider the vector representation here? Whenever on any one symbol, on any one letter, bar is present, this is called bar. This is called bar. On any one letter, bar is present, that is a vector. In the problem, R1 bar, R2 bar, R3 bar, vectors are given, and that's why here I considered vector representation RCM bar. Are you getting? Okay. Now, RCM bar is equal to M1. What is the mass of the first particle? What's the 1 ma? 1. What is the R1 bar? R1 bar is nothing but I cap plus 4j cap plus k cap plus M2. What is the mass of the second particle? 2. What is the R2 bar? I cap plus j cap plus k cap. This is the M2 R2 bar plus M3. What is the mass of the third particle? 3 kg. M3 replace with 3 kg. R3 bar. What is the R3 bar? 2I cap minus j cap minus 2k cap whole divided by M1 plus M2 plus M3. What is the M1? 1. What is the M2? 2. What is the M3? 3. M1 plus M2 plus M3. Okay, and now R CM bar is equal to I cap in this 2 into I cap, multiply with every term, 2 into I cap, 2 I cap, here 3 into 2 I cap, 3 into 2 I cap, 6 I cap, all I caps I kept one side, plus now J cap, 1 into 4 J cap, 4 J cap, 2 into J cap, 2 J cap. Next here, 3 into minus j cap, nothing but minus j cap. Here 1 is present. 3 into 1, 3. Plus into minus, minus 3 j cap. Plus, now k cap. 1 into k cap, k cap. 2 into k cap, plus 2 k cap. 3 into 2, 6. Plus into minus, minus 6 k cap. By 1 plus 2 plus 3, that is nothing but 6. Now, RCM bar is equal to I cap 2 plus 1, 3 plus 6, 9 I cap plus 4 plus 2, 6. Here minus 3 is present. 6 minus 3, 3. 3 J cap plus 1 plus 2, 3. 3 minus 6, 3 minus 6, 3 minus 6. Minus is more. So minus 3 K cap by 6. Now RCM bar is equal to, now this I am writing it as 9I cap plus 3 J cap plus into minus, minus 3 K cap by 6. Take the 3 as common in this, 3 as common. Then 3I cap plus J cap, if you take out 3 J cap, if you take out 3 minus K cap by 6. 3 ones are, 3 twos are. Now RCM bar is equal to 3I cap plus J cap minus K cap by 2. This is the position of the center of mass, position of the center of mass of these three position vectors. Okay, just take a look on this. Fine. Now I'm taking another problem. I'm taking another problem. Three particles of masses 0.50 kg, 1 kg, 1.5 kg are placed at the three corners of right angle triangle of sides 3 centimeter, 4 centimeter, and 5 centimeter as shown in the figure. So this is the diagram given in the problem. This is 0.50 is present here, 1 kg is present at this corner, and then 1.5 kg is present at this corner. Locate the center of mass of the system. So like this one, three masses are present on any one structure, then what is the position of center of mass? Position of center of mass related to these three masses that we need to calculate. Okay, now for that, at first we need to take the coordinate system. This is one right angle triangle, no? You consider, listen carefully. Here I am taking that. This is x-axis and this is y-axis. Now this I am taking it as 0, 0 origin, 0, 0. This I am taking it as origin. Now this is x-axis. On the x-axis, what is the distance of 1 kg? 4 centimeter. 4 centimeter is the distance of 1 kg. So this I am writing it as 4, 0. Why? Because this mass is on the x-axis. Okay, if any line intersects the x-axis, then y coordinate is 0. So on the x-axis, y coordinate is 0. On the y-axis, x coordinate is 0. Okay, very simple. Now come to the 1.5 kg. This 1.5 kg is on the y-axis. On the y-axis, x coordinate is 0. On the y-axis, x coordinate is 0. So 0, what is the distance of 1.5 kg from the origin? What is the distance from the origin? This 1.5 kg is at 3 centimeter. So 0, 3. 0, 3. Now I am taking the coordinates x1, y1, 0, 0. 0, 0. x2, y2, 4, 0. x3, y3, what's that? 0, 3. Like these coordinates I consider three masses, and that's why here I need to calculate at first xcm m1 x1 plus m2 x2 plus m3 x3 by m1 plus m2 plus m3 m1 plus m2 plus m3. Okay, now m1 x1, what is the m1? 0.50. x1, what is the value of x1? 0. Plus, what about the m2? 1 kg. 1 kg. What about the x2? 4. m3, what is the value of m3? 1.5. What about x3? 0. x3 0. By m1 plus m2 plus m3. 0.50 plus 1 plus 1.5. Now 0 into anything equal to 0. 4 into 1, 4. 0 into anything equal to 0. No need to write. By 1.5 plus 0.5, 2. 2 plus 1, 3. 4 by 3. This is xcm. This is XCM 4 by 3. Now come across the YCM. YCM is equal to what's the value? M1Y1 plus M2Y2 plus M3Y3 by M1 plus M2 plus M3. Now YCM is equal to M1. What is the M1? 0.50. 0.50. That is M1. Y1. What is the Y1? 0. What is M2? 1 kg. What about Y2? That also 0. Plus M3. What about M3? 1.5. What about Y3? 3. Y3 is 3. Y3 is 3 by M1 plus M2 plus M3. 0.50, 0.50 plus 1 plus 1.5. Then YCM is equal to, this is 0 into anything equal to 0, 0 into anything equal to 0, 3 into 1.5, 15 3s are 45, one decimal point is present, 4.5, 1.1, 1.5 plus 0.5, 2 plus 1, 3, 4.5 by 3. So 4.5 by 3 is equal to what's the value? If you calculate that, then that is 1.5 centimeter. Now here we need to consider the topic it as XCM. We used to write like this: XCM comma YCM is equal to, how come we mentioned that? 4 by 3 centimeter comma 1.5 centimeter. Like this we can solve this problem. Okay, now I'm taking another problem. This is another problem. Find the position of center of mass of 4 particle system which are at the vertices of a parallelogram. This is one parallelogram given in the problem. Unlike that, one side is A, the other side is B. At all the vertices of this parallelogram, identical masses are present. Identical means same. M, 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 and M. Some angle representation also given in the problem. With the x-axis, the side is making an angle theta. Now we need to calculate position of center of mass of this structure. Okay, so now for that, at first we need to take the coordinates. We need to take the coordinates. Okay, now in this origin, this is the origin. That origin here we are mentioning it as 0, 0, 0, 0. And what about this? This is on the x-axis. On the x-axis, the y component is 0. Y coordinate is 0. Y coordinate is 0. So, comma 0. What is the x coordinate? From the origin, this mass is at small a distance. So, small a comma 0. That is the coordinate of the another mass which is on the x-axis. Are you getting? Okay, 0, comma 0. And one more mass is present on the x-axis, and this is that on the x-axis y coordinate is 0. So y value is 0. This second mass is at a distance from the origin. From the origin, what is the distance of this second mass? A. So a comma 0. And now come across this point. Here one mass is present. Here one mass is present. We need to calculate those coordinates. For that purpose, here I'm taking that one perpendicular line like this. One perpendicular line like this. Okay. Now, if this is B, this is also B. Why? Because in parallelogram, opposite sides are equal. So if this is B, this also equal to B. Okay. And now here, this is the B. You can say it as a vector. B is making an angle theta with a horizontal. This is horizontal. B is making an angle theta with the horizontal. So it resolved into two components. Concentrate on my words. B resolved into two components. Along the x-axis, B cos theta. Then along the y-axis, here we are taking it as B sin theta. B sin theta. Okay. Along the x-axis, what is the value? B cos theta. Along y-axis, what is the value? B sin theta. Now, I need to take the x-coordinate of this mass. X-coordinate. From here to here, I need to calculate, this is the mass. I need to calculate from here to here. From here to here, what is the distance? A. From here to here, what is the distance? B cos theta. Once again, from origin to capital A, what is the distance? Small a. From capital A to, for example, you treat it as D. You treat it as D. A to D. What is the distance? Just now we consider the component B cos theta. So what is the total distance? A plus B cos theta. This is the x coordinate. This is the x coordinate of this mass. This mass. Okay. Then what about the y coordinate? Just now y component, what is the value? B sin theta. This itself serves the purpose of y coordinate. B sin theta. Why? Because both sides are equal. Here to here B sin theta and here to here also B sin theta. Opposite sides B sin theta. Are you getting? Okay. Now another mass is left here. I need to calculate those coordinates. Same thing once again. Same thing once again. Again I can say one perpendicular line like this. One perpendicular line. So B is resolved into components. Here this is B cos theta and vertically what is the value? B sin theta. Vertically B sin theta. What is the x coordinate for this? From here to here. O to A. O to small a. O to small a. What is the distance? B cos theta. So here I consider this is the point, no? This is the point, no? From here to here, what is the distance? B cos theta. That is the x coordinate. Y coordinate. What is the y coordinate here? What is the y coordinate here? B sin theta. That we consider it as B sin theta as the y coordinate. At first, if you want to calculate the center of mass of any one particular diagram, then at first we need to calculate the coordinates of that. At first we need to calculate the coordinates of those. Okay. Now, so if you consider like that, at first, here I'm taking those terms like this: x1, y1, four masses are there, and that's why x2, y2, x3, y3, x4, y4. x1, y1 is equal to 0, 0. x2, y2 is equal to, what is the x2, y2? Small a, 0. x3, y3 is equal to a plus b cos theta, b sin theta. x4, y4 is equal to b cos theta, b sin theta. B cos theta, b sin theta. Like that, here we consider at first different masses, nothing but all the masses are at four vertices. And related to the masses, we need to calculate the coordinates x1, y1, x2, y2, x3, y3, and x4, y4. Is it clear so far? And now, here, four different masses are there. Four different coordinates are present. So, four terms are present here in the formula. So, here I am taking that at first xcm. xcm is equal to m1 x1 plus m2 x2 plus m3 x3 plus m4 x4 by m1 plus m2 plus m3 plus m4. m1 plus m2 plus m3 plus m4. Okay. Now xcm is equal to m1. What is the m1? M only. x1, this is the x1, 0. m2, m only. x2, what is the value? A. Plus m3, m only. x3, a plus b cos theta. Plus m4, again same mass. x4, b cos theta. By m plus m1 plus m2 plus m3 plus m4, identical masses, m plus m plus m plus m, 4m. Now 0 into anything equal to 0. Take out the m as common and cancel numerator as well as the denominator, and then xcm is equal to a, and here b cos theta, a plus b cos theta, a plus b cos theta. A 2 times repeated, 2a. B cos theta also 2 times repeated, 2b cos theta, by 4 left. Now 2 as common, 2 ones are, and denominator of 4 is present, and 2 ones are, 2 twos are, then that is nothing but a plus b cos theta by 2. That is the xcm. A plus b cos theta by 2. That is the xcm. And then next we need to calculate the ycm. And this is the xcm. Just take a look on this. Next we need to calculate the ycm. We need to calculate the ycm. ycm is equal to m1 y1 plus m2 y2 plus m3 y3 plus m4 y4 by m1 plus m2 plus m3 plus m4. Now ycm is equal to m1, m only. y1, see here, what is the y1? 0, 0. m2, m only. y2 means again 0, plus m3, m only. y3, what is the value? b sin theta, m4, m only. y4, what is the value? b sin theta again, by m1, m2, m3, m4, all m's only, 4 times repeated, 4m. Then ycm is equal to 0 into anything equal to 0, 0 into anything equal to 0. No need to write this. Take out the m as common. So numerator and denominator m can be cancelled. b sin theta plus b sin theta, 2 times repeated, 2b sin theta by, what's the value? 4, by 4. Okay, 2 ones are, 2 twos are, what's the value? b sin theta by 2. Now I need to represent like this: xcm comma ycm is equal to xcm comma ycm is equal to, how come we consider that? xcm is nothing but a plus b cos theta by 2. Previously just now we derived that a plus b cos theta by 2, that is the xcm, and ycm is nothing but b sin theta by 2. This is about xcm and ycm. Okay, now I'm taking another problem. I'm taking another problem. If the center of mass of 3 particles of masses of 1 kg, 2 kg, 3 kg is at 2, 2, 2 meters. Okay, then where should the fourth particle of mass 4 kg be placed so that the combined center of mass may be at 0, 0, 0. Okay, so in this, we're taking a square, right? So now here, at first, this is the, if only 3 particles are present, 1, 2 kg, 3 kg, only 3 particles are present. What about the center of mass? XCM is 2, YCM is 2, and ZCM is 2. Once again, if 3 particles only present, only 3 particles, 1 kg, 2 kg, and 3 kg, M1 is equal to 1 kg, M2 is equal to 2 kg, M3 is equal to 3 kg. M3 is equal to 3 kg. So only 3 particles are present. Then what about the center of mass? XCM, YCM, ZCM is equal to, how come we consider that? 2, 2, 2. What about that? 2, 2, 2. Where should a fourth particle of mass 4 kg is present? Now it means what? Apart from the 3 particles, one more particle is going to be added. Okay, one more particle is adding to the system. That is the fourth particle. What is the mass of the fourth particle given in the problem? What's the value? 4 kg. So if the additionally fourth particle added to the system, then the center of mass can be changed. What is the new center of mass? That new center of mass is 0, 0, 0. If only 3 particles are present, the position of center of mass is 2, 2, 2. If fourth particle is added to the system, then what about that? 0, 0, 0. Now, what is the question? What is the question? Where should a fourth particle of mass? We need to calculate the coordinates of the fourth particle. We need to calculate the coordinates of the fourth particle. Are you getting? Coordinates of the fourth particle. Okay. Now, at first I am taking XCM is equal to M1 X1 plus M2 X2 plus M3 X3 by M1 plus M2 plus M3. This I am taking it as case 1. I am taking it as case 1. So in 2 cases I am solving this problem. Okay. XCM is equal to M1 X1 plus M2 X2 plus M3 X3 by M1 plus M2 plus M3. This formula already you know that. Okay. Now, XCM is equal to XCM. What about the XCM? Here just now we considered that XCM is equal to, initially what's the value? Only 3 particles are present. 3 particles are present. What about the XCM? 2. So in the place of XCM, here I am taking 2. M1. What is the M1? What is the M1? 1 kg. We don't know X1. Plus M2, 2 kg. We don't know X2. Plus M3, 3 kg. We don't know X3. By M1 plus M2 plus M3. 1 plus 2 plus 3, 6. 6 2s are cross multiplication, 12. So X1 plus 2 into X2 plus 3X3 is equal to, what's the value? 12. This is equation 1. This is equation 1. Okay. Now case 2. Case 2. Fourth particle is adding. So the position of center of mass changed. XCM, I consider it as XCM dash. New center of mass. If notation is changing means the value changed. So M1, now here fourth mass added. And that's why instead of 3 terms, here we will get 4 terms. M3, X3. Additionally, we consider M4, X4 by M1 plus M2 plus M3 plus M4. M1 plus M2 plus M3 plus M4. X dash CM. What about the new center of mass? That new center of mass is 0, 0, 0. XCM 0, YCM 0, ZCM 0. So now the new center of mass is, initially here we are taking it as, first one is 0. M1, 1 kg. X1. M2, 2 kg. x2 plus m3 3 kg x3 m4 4 kg x4 by m1 1 plus 2 plus 3 plus 4. 4 plus 3, 7 plus 2, 9 plus 1, 10. 10 into 0, 0, cross multiplication. x1 plus 2x2 plus 3x3 plus 4x4. If you take the cross multiplication, this value into this value, that became as 0. Now, as you know that x1 plus 2x2 plus 3x3 is equal to what's the value? 12. x1 plus 2x2 plus 3x3 is equal to 12. Here also same term is present. x1 plus 2x2 plus 3x3. What about that value? 12. So replace this entire value with 12 plus 4x4 equal to 0. That implies 4x4 is equal to minus 12. x4 is equal to minus 3. This is the x coordinate of the fourth particle. x4 is equal to what's the value? Minus 3. In the same way, YCM also 0, ZCM also 0. It means x4 is equal to minus 3, y4 also equal to minus 3, z4 also equal to minus 3. It means the fourth particle having the coordinates minus 3, minus 3, minus 3. Okay, just take a look on this.